Hello! Today I'm going to show you how to build a file search engine complete with GUI interface. So if you're looking for a cool project to build out your portfolio, or if you're like me and you just want a quicker way to find your files, then this video is for you. I'm going to be building this project on a Windows 10 machine, but if you're using Linux, no problem. You can use this as well. It's platform agnostic. I'm going to be working through this project in 3 steps. Step number 1, building out the search engine class. Step number 2, building out the GUI. And step number 3, putting it all together. So let's get started. The function that's going to do the heavy lifting as far as indexing the drive is the walk function in the OS module. The walk function is a generator function, which means it yields one result at a time on demand, either by iterating over it or by calling it with next. The function yields a tuple of items as it traverses a directory, the current or root path, a list of directories inside the current path, and a list of files in the current path. We'll mainly be concerned with the root path and the list of files in that path. Now that you know a little bit about the generator function we're going to use to index the drive, let's start building out the program. Step number 1. The first thing I'm going to do is import the packages I'll need for this program. Next, I'm going to create a search engine class and outline the methods that I'm going to need. So in this class, I need to initialize a few items. File index. This is going to be a list that will store the directory index that is returned by the os.walk function. Results. This is a list that will store the results of each search. Matches. This is going to be used as a counter to count each matching file. Records. This is going to be used as a counter to count each record searched. So these last two together will give me the number of records searched and the number of matches from the record search, which is an interesting information to print to screen. Now let's outline a few methods that we're going to need for this class. I'm defining a create new index method that will create a new index starting with the root path given as an argument. And then I'm going to save that index to a pickle file so that I can perform subsequent searches quickly without having to re-index the drive each time. Next, I'm defining a method to load existing index. And this will load the index into the program that was previously created with the create new index method. And I want to load this each time the program is started, if it exists, so that I can immediately begin searching the drive if I want to without having to re-index the files. Finally, I'm defining a search method. This is going to accept a few arguments. The most important is obviously the term that I want to search for, but I'd like to indicate the type of search being performed in the search type parameter that includes options for contains, starts with, and ends with. I'll default to contains, and these 3 options will give my search a lot of flexibility. I'm initially going to include these as method arguments, but eventually I'll put these in the feed of information from the GUI, so they'll be passed from the GUI instead of input directly. And finally, I'm going to save the results of the search to a text file, so I want to make sure that I write functionality for that. Next, let's flesh out the search engine class. The create new index method. There are 2 things that this method needs to do. First, it's to create the index, and then second is to save that index to a pickle file. So type self.file_index equals, then let's use a list comprehension to unpack the os.walk generator. Even though the generator returns a tuple of 3 items, I really only need the first and last, which is the root path and the list of files. Next, let's create the functionality to save the index to a pickle file. So type with open file_index.pkl wb as f, and then pickle.dump self.file_index, and then I'm going to pass f as the file I want to write to. So what this basically means is I'm opening a file called file_pickle.pkl. If it doesn't exist, it will be created, and then I'm going to dump the contents of the file index list into that pickle file. Okay, that's done. Let's move on to the load existing index method. With this method, all I really want to do is open the file index if it exists. However, if I try to open a file in read-only mode and it doesn't exist, then it's going to return an error. So because of that, I'm going to use a try and accept clause to catch that error. So go ahead and type try and accept. Then let's add the file open code. Under try, type with open file underscore index.pkl, and then RB, which is read binary, as if. So it's basically the same file that we created in the previous step. And then we're going to set the file index equal to the value of pickle.load in that file. Then under accept, type self.file underscore index equals, and then we're going to have it return an empty list. That way, if nothing else happens, then at least we'll have an empty file index. All right, now let's flesh out the search function. This search function is going to do three things. Number one, it's going to reset some variables that are initialized initially. It's going to perform the search, and then it's going to save the search results to a file. So every time I perform a search, I want to make sure that that I reset the results, the matches, and the records. Now, results is a list, so for that I can use the clear method. The other two I'll just set as the integer 0. Next, I need to find the search term in the list of files in the file index. So if you remember, each row in the file index is a path, and then a list of files in that path. So what I'll need to do is iterate first over each row in the file index, and then over each file in the list of files in that row. So every time I iterate over a file, I'm going to increment the records variable, and this will keep a running count of records searched. Next, I need to find the search term in the file name, and since there are going to be three different search options, I'm going to need to test for three different scenarios depending on the type of search being performed. So by default, I'm looking for file names that contain the search term. So in order to do this, I'm going to use a sequence of if/or statements to test for the three different scenarios. If any of these statements is true, then I'm going to add the path and file name to the results list. Otherwise, I'll continue to the next search term. So type if, and then in parentheses, search underscore type is equal to contains and term in file. One thing I'm going to do here is account for capitalization. Python is case sensitive, but I don't really care about case in my search results. So I'm going to transform all the file names in search term to lowercase by adding .lower at the end. So then type search underscore type is equal to starts with. Now here I'm going to use the starts with string method. So and file.lower starts with, and then I'm going to pass the term that's lowercase. Okay, and then or search type is equal to ends with, and file.lower ends with term.lower. Okay, so if any of these things evaluates to true, I want to append the path and name to the list of results. However, one thing I need to do is to change the format of the path. If you're using Windows like I am, then the os.walk function will return a path with backslashes. However, I want to show forward slashes just because it's cleaner, because backslashes are basically escape characters, and so it gets kind of messy. So I'm just going to use the string replace method to change those from backslashes to forward slashes, and then I'm going to concatenate a forward slash and the file name in order to create a full file path, which I'll add to the results list. And then I'm going to increment the matches so that I can keep a count of matches. And then finally, I'm going to save the results to file. So type with open search results.txt w as f for row and self.results, and then write the row. But I'm also going to add the next line escape, the backslash in, and that's in order to put the next item on a new line. All right, so now that that's done, we can actually test the functionality by writing out a quick test function. And this is going to check output files and valid search results. So create a new search engine object by typing s equals search engine, and then s.create new index, and we'll use the index, the path C. And then we're going to use the search method to search for gecko. Next, I'm going to print the results to the screen, and I'm going to pass variables that I collect from matches and records using the string formatting method. And then I'm going to iterate over each of the results and print those to the screen as well. Then let's call the test function and run. What this should do is create a new index of the C drive and then save that index to a pickle file. Then it should search the index for all files that contain the word gecko. Good, the results printed to screen. Now let's see if the files were saved successfully. And yes, there they are. Okay, so let's do one more test, and this time I'm going to load the existing index in instead of creating a new one, and I should get results pretty fast. So all I need to do is use the s.loadExistingIndex and run that. And great, our search class is working as expected, and now we can move on to step 2 and create the GUI class. Let's create a GUI. Believe it or not, this is going to be very simple because we're going to use the PySimpleGUI package, and it really is simple. So first, make sure that you've installed the PySimpleGUI module with either pip or conda by typing in pip install PySimpleGUI or conda install PySimpleGUI in your command line. Next, we're going to add this to the import in our project by typing in import PySimpleGUI as SG, and make sure that you capitalize GUI. Okay, so let's create a class called GUI, and in this class we're going to initialize 2 objects, a layout and a window. And these are the only 2 objects really that you need to open up and start a GUI. The window object represents the physical window that opens up on the screen, and I'm going to pass the string file search engine, which will be the name of the program that shows up on the upper left-hand side of the window. And then I'll attach to that the layout that we're going to build next. And that is all that is required there. There are many more options and settings, and I'm just going to go over what is required for this project. But if you're interested in learning more about PySimpleGUI and the huge amount of customizations you can make, check the video description for a link to the documentation. Okay, now for the layout. Before you build out a GUI, it's always good to sketch out what you want to build. In this case, we already have a template of what we want it to look like. You can see that if we look at this in terms of rows, in the first row we have a text field, an input field, a few radio buttons. Then in the next row we have a text field, an input field, and some buttons. Then in the last row we have an output element. So if you think about this design in terms of rows, where each row represents a list of elements, this is the intuitive way that PySimpleGUI package was built. So using this intuition, let's go back to the layout code and start with a list. This outer list is going to be the container for all of the rows in the layout, where each row is represented by a new list. So just so you know what I mean, I'm going to add a few elements to each row, and then I'll run the GUI so that you can see what it looks like as we add additional elements. And this will help you to see how this thing actually works, because it really is that simple. In the first row, I'm going to add a text box called search term and an input box. Okay, let's run this. But in order to do that, I need to create a GUI object. So scroll down to the bottom of your code and let's create a new test function. So we're going to define test3 to test the GUI interface. And we're going to create g equals GUI, g.windowRead. And read is the method used to basically read all of the code necessary to pop up the window. So when we run this, we should see a GUI pop up on the screen. And there it is. You can see the test field and then the input text next to it. All right, so let's go ahead and add the radio buttons. The first button will be contains, the second starts with, and the last ends with. One requirement for the radio buttons is that you have to add a group ID. And the reason for this is that the program needs to know what other choices this radio button is a part of. So I'll add the group ID choice to all of these. Now that those are added, let's run this code again. And now you can see that I have 3 radio buttons, and if I select one, the others are unselected, and this is what we want. It means they're in the same group. Okay, now let's add another row. The next row will include a text box called root path, an input box, and a folder browse button, and 2 other buttons called reindex and search, which will be used to index and search as their name suggests. The folder browse element is a cool built-in element that opens up a folder explorer and allows you to choose a folder, and then it inserts that choice into the input box of your choice. However, by default, it will be inserted into the input box directly preceding it. So because that's actually what we want, we'll leave this as is. And then we can run the code again and see what it looks like. Okay, so now you can see that we have 2 rows in our GUI. And now we can add the final row, which is the output. So go back to your code and start a new line or a new row with a new list. And in this one, we're going to use the built-in output element, which shows anything that would typically be printed to the command line when your program runs. And I'm going to go ahead and give this a size of 130. Okay, let's run that and see what we have. Great. Although it doesn't look exactly how we want, the overall layout is looking good. Now we just need to fine-tune it. Because adding additional details is going to make these rows really long, I'm going to go ahead and put these elements on different rows, but will still be possible to see what row they belong to because of the list brackets separating each row. Okay, so I'm going to start by resizing all of the buttons and text fields to 10 wide and 1 high. Next, I'm going to resize the inputs to 45 wide and 1 high. Next, just a few other adjustments. I'm going to set the focus of the search term input to true, and this will cause the cursor to default to that element when the program is started. I also want to add C as the default path to the root path input, but you can change this to whatever you want, including to nothing if you wish. And finally, I want to bind the return key to the search button. And what this will do is when you hit the return or enter key on your keyboard, it will automatically trigger this search button. Okay, now with all that, let's run this again. Now it's looking very good. The only thing left to do actually is to change the color theme. And believe it or not, that is really easy. Underneath the import statement, type sg.change_look_and_feel in camel case, and then into that pass dark. And that is all you need to do. There are other color themes that you can use, and they are in the PySimpleGUI documentation. But let's go ahead and run this and see what it looks like. And there we go. The GUI layout is now ready. However, we still need to do a few more things before we connect this to the search engine, and that is to set up the event loop. And then we can go to the next step, which is to connect the GUI to the search engine. Okay, so let's set up the event loop. If you've worked with GUIs before, then you're familiar with the event loop, but if not, basically the GUI is running in a loop and listening for events such as mouse clicks, button presses, etc. And when certain events occur, you can trigger certain code to execute. So in PySimpleGUI, this is actually pretty simple. Scroll down to the bottom, and we're going to modify the GUI test and create an event loop that is going to keep the window active and print the events to the output element as they happen. So go ahead and type in while true. The window read actually returns a tuple containing the event and either a list or dictionary of values from the other elements on the screen. So what we're going to do is unpack those from that read method. So what's going to happen is every time an event occurs, the name of the event and the values of the other elements will be printed to the output element. Okay, so let's run this thing. Let's put in a search term and select contains as the search type. We'll leave the default path and then let's click on search. You can see that when I click search, the event is the first item printed, followed by a list of values that correspond to the values of the other elements on the screen: the search term, true or false status of the radio buttons, and the file path name. If I change a few things here, such as the search term and the search type, and then click reindex, you'll see I get a similar output reflecting the different values. These two buttons, reindex and search, are really the only buttons other than the X close button that actually creates events. The browse button doesn't create an event that is caught in the event loop, but rather it simply opens up a file browser dialog and allows you to select a path. In order to make the events and values easier to use and to read, what we can do is actually change this list to a dictionary, and all we need to do is add keys to the objects that show up in this list. So let's go ahead and close this window and do that. So for each of these elements, we're going to add a key. So let's start with the search term, and I'm going to give it the key name term. So type key equals and then term in uppercase letters. The radio buttons, I'm going to give key names as it basically matches their labels. So contains, starts with, and ends with. I'm going to give the root path input the key path. Finally, I'm going to give the reindex and search buttons the key underscore index underscore and underscore search underscore. The naming convention I've chosen for value elements and event elements is purely personal preference, so use whatever naming convention you want. Okay, so now when I run the program and print the events and values to the screen, I should see a dictionary returned instead of a list, and this will make the values much easier to get to. First, you'll notice that when I open up the program, there's no default radio button selected, so let's go ahead and change that before we run this. So close that window, and if we go back to the code on the contains radio button, let's add the parameter default equals true. And this will cause the radio button to be selected by default when we start the program. So you can see the contains option is selected by default. Let's type in a search term gecko and go ahead and click the search button. Now you can see the key name of the event as well as the key name and values of each element that contains a value. And finally, now that the event loop is set up with the events and values, we can now connect this thing to the search engine. So let's go. Step 3, putting it all together. What we need to do first is transfer variables. And what I mean by that is originally our search engine was getting values through arguments passed directly into the function. However, now that we have a GUI, some of those values will be taken from the elements in the GUI. So let's make just a few changes in the code so that the search engine is getting those values from the GUI instead of directly. The first method we need to change is the create new index method. And this accepts a root path argument. However, we can now get that information from the values dictionary that's returned by the GUI event loop. So instead of passing root path as an argument, we'll pass values, which is going to be the dictionary returned from the GUI. Then we'll need to create a root path variable and set it equal to the dictionary value of the root path, which, if you remember, has the key of path. And that's it for that method. The load existing index method is pulling data from a pickle file, so nothing needs to change there. Next, let's take a look at the search function. Here, the original code accepts arguments for the term and search type. However, we know that we can now get this data from the values dictionary returned by the GUI, so we can replace those arguments with the values dictionary. So similar to the create new index method, we're going to set the term of the variable using the values dictionary by looking up the value for the key term. We can't handle the search type in the same way because it's in 3 different radio buttons, but we actually don't need to do much to adjust this piece either. So if you look at the if statement, I'm essentially returning a Boolean value for search type equals. Well, the radio buttons return Boolean values, so instead of using search type equals, I can instead look up the value for each search type key and get the same exact return value. So for contains, I'll replace search type equals contains with values contains with contains returning the value true or false. And I'll do the same for the other search types. Okay, so far so good. Now we can connect the buttons to the search engine method. Now that I've transferred the variables from direct input to the GUI, I can now connect the reindex and search buttons to the search engine methods that I've defined in the search engine class. And this is done in the event loop. So let's scroll down to the event loop and make some modifications. Since this is going to be the final loop we create, let's go ahead and define a main function. Then I'm going to create a GUI and search engine object. And next, I want the search engine to load an existing index if one exists. So let's go ahead and now start the loop. So type while, and then just as before, I'm going to unpack the event and values from the tuples returned by the window read method. And if you remember from the output element, there are two events that can be triggered, the index and search events. However, there's also a none type event, which can also occur if the window is closed. So let's use if statements to tell the program what to do if any of those three kinds of events happen. First is the none event, and what I want to do if that occurs is I want to break out of the loop, and this will close the program. Next, if the event is equal to index, I'm going to call the create new index method, and if you remember, I need to pass the values dictionary as an argument so that I can look up the root path. I also want to go ahead and print a message to the output element that indicates that a new index has been created. Finally, if the event is equal to search, I'm going to call the search method and pass the values dictionary so I can look up the search term and the search type. I also want to print the results to the output element, so I'm going to iterate over each result in the results list and print that to the screen. And then for information purposes, I'm going to print the number of records searched and matches found, as well as notify the user that the results have been saved to the working directory in the search results text file. By the way, the working directory is by default whatever directory that this script is running in. Okay, now that that's done, let's call this main function and run this thing. Okay, so we know we've already created an index so that it should be loaded already. So we can test this by searching for the term gecko. And just like that, I have a list of results with the statistics shown below. Out of 900,000 records, there were 9 matches. And if I navigate to the working directory, I can see that those results were saved in the text file. Okay, so let's create a new index using my documents folder. So click on the Browse button and select Documents. Click Enter or OK, and then that should populate the root path input element. Then click on Reindex. After that indexes, I get a message saying that the folder has been indexed. Okay, so let's search for all files ending in the term text. So I'll type text in the term, and then I'll select ends with, and then click the search button. And just like that, it searched over 16,000 files and found 184 matches, which are printed to the screen. And if we go and look at the results text file, we can see that they're there also. So there you go, you've now built a really cool program complete with a GUI that you can now add to your portfolio. And there are a lot of other features that you could add to this program, but I'll leave that up to you and your creative genius. I hope you've learned a lot in this video. If so, smash that like button and consider subscribing to get notified of future projects like this that I post. See you later.